Hi and welcome to this new awesome tutorial. Today we will create this map using R where we have the distribution of the number of wildfires in one province of Spain, the province of Ourense. So here you can see, depending on the color, the number of wildfires that we had in the last century. So this means between the years 2000 to 2024. So another cool thing that we have here is an inset map where we specify where this province is located within Spain. And we will learn also how to add this small map into our main map. The data that we'll use in this tutorial comes from the European Forest Fire Information System, also known as the EFFIS. So here you have a lot of data about wildfires, but if you want to find the raw data, you should go here to Apps, Data and Services, and here you have some data that you can download and use it for your analysis. The data that we will use in this tutorial is this shapefile, which is the real-time updated burnt areas database. And to download it, we will right-click on it, copy the URL, and later we will use that URL inside R to download the dataset. Alright, so we'll start going throughout the practice. And like always, I will start loading the packages using the pacman package. And here we'll use the FS package to access the file system, disco R to download the boundaries of the study area and the countries of the world, the map view package to create some interactive maps, the patchwork package to add the inset map in the end to the ggplot2 object, the SF and Terra package, which are used to manipulate spatial data. They can be used both for vectorial data and the Terra package for raster data. The tidy Terra to add Terra objects to ggplot2, and finally the tidyverse. So I will start loading the study area using the gisco get nuts function. I want the highest resolution, the nuts level 3, and the country Spain. So the nuts level 3 in the case of Spain is for the provinces. And here I'm filtering the province of Ourense and transforming the coordinate reference system to this one. So if I print this in the console, we see that we have only one simple feature collection, I mean one feature only, and it's the province of Ourense. And just to locate us, I will use map view to show you where is this. So I will execute this and we can see that it's in the northwest of Spain. So now we will continue, and first I want to convert it to a spat vector using the vect function. And this is because later we will need the format that is provided by the Terra package and not the format of the SF package. So here we are maintaining the spatial data as it is, but with a new format, which I repeat is from the Terra package, but the format that we had before is from the SF package. So now I will download the wildfires data that we saw before from the EFFIS webpage. So here we have this URL, and I'm creating two different paths here. So the dest file zip, which is the path in the temporary directory with zip extension, and then I'm removing the zip extension. So this will be the name when we extract the contents of the zip file. So first I will download the data by using the URL. The destination file will be the zipped file, and I will use the binary mode. And this will take 1 minute or so. Alright, now it's finished. We downloaded a total of 143 megabytes of data. We can visualize the directory tree by using this dir_tree function from the FS package. So I will minimize this, and here we have some other temporary files that were downloaded by the mapview package, but we are interested on seeing that we have this effisdata.zip file. So now we will unzip it by using the unzip function. We need to tell this function where the zip file is and where we want to extract it. So now if I print the directory tree again, and if I scroll up, we will see that now we have here the extracted data and it's a shape file. So what I'm doing here is to paste the path to this shapefile object so we can read it with the readsf function and transform it to this coordinate reference system. So I will execute it, and once it's done, I will print it in the console so we can see how this dataset look like. Alright, here we have it. We have almost 78,000 features, so each observation is one wildfire, and they are all in Europe. So now I need also the world data because I will need it for the inset map. So I will execute this function, and if I use the plot function in the geometry of this object, we will see that this is just one spatial object with all the countries of the world. Alright, so now we will move on to the next step, which is preparing the data. And first we will filter the wildfires that belong to our study area, which is the province of Ourense. So first I can take this dataset, wildfires SF, and use the glimpse function. So I will minimize this, and we see all the different variables that we have. And one of them is the province. And here we can see different provinces that belong to Italy, Portugal, Spain, and so on. So if I use a dplyr filter and print this object again in the console, we see that we have a total of 1180 wildfires. But there is one problem with this approach, and I will show you why. If I take again the wildfires SF object and I convert it into a table, and now I count the frequency of the province column and execute this, you will see that we have many provinces with this question mark. And this is a problem because these provinces, they don't have the name, but maybe they can belong to Ourense. And in the case that we want to filter those wildfires that are inside Ourense without taking into account this variable, we can use the ST intersection. And in this way, we will filter the features spatially. So what this means is that we will introduce first one polygon for the province of Ourense and then all the wildfires. And this function will filter those that are inside the boundaries of this province. And here I need to use this stMakeValid because if I comment this out and I try to execute it, you will see that there is some topology exception in some of the geometries. So what we need to do is to fix these topology errors by using the stMakeValid function. And now that we are done, we can print this new object in the console, and we see that now we have about 300 more wildfires. And this is something important because when you are working with the spatial data and you are interested on filtering some wildfires based on some area where you have the polygon, it's more recommended to use a spatial filter because they are more exact. So now we will go to the next step, which is counting the number of wildfires that we have in each pixel. And this is because in the wildfires object that we have now, we have these total wildfires, but these polygons may overlap each other. So we need to know how many of these wildfires are overlapping in different pixels of one determined size that we will specify here. So first what I will do is to create two columns that we will need in a moment, and I will explain them now after executing this. I will print this object in the console, so we added one identifier, which is the row column, so it's a unique identifier, and then the fire column, which is the number 1 for all of them. And this will be necessary for the rasterization, for the rasterize operation. So the next step is to split the data into a list because it's easier to map over the list. So I will execute this, and here I'm taking the SF object, which has again 1300 wildfires, and I'm using the ID column to separate them in different elements of a list. So if I print this in the console, it will take a while because there are 1300. But basically what we did is to put each of the rows of this dataset into one different element of a list. So there we have it. We see until the element 1000, but you see with this $sign that we have different elements of the list. And if I use now the length function, we see that this is the length of the list. So it's each element of the list. And I repeat, this is necessary because later we will use the map function to iterate over all of these elements. But before iterating over them, we need to create a raster template. So here I'm using the rast function to create a raster with the extent of the province of Ourense, a resolution of 100 meters, and the same coordinate reference system as Ourense. So if I execute this is basically one spat raster without values, but with the same extent of the province of Ourense. And this template is necessary because when we use this rasterize function, we are rasterizing the wildfires, so each element of the list that we created here before, but we need to rasterize it to one extent, and the extent must be this raster that we created. Because if we don't use this, each of the small wildfires will be in some area of the province, and let's say that it uses the bounding box, so we have different, in the end we would have different wildfires with different extent. So just to illustrate what this function does, I will take it here to the console, and instead of using here x, I will use the wildfires sf list, and I will take the first element. So if I execute this, and I will store it as test wildfire, and I will use the plot function on test wildfire. So what this function does is to take the extent of Ourense. Actually I can add it here with plot st geometry of Ourense sf, and I will add the argument add equals to true. And there we have it. So you see that the raster extent is the bounding box of Ourense, but the first wildfire is only here. So this yellow area is the extent of the wildfire in raster format, and with the spatial resolution of 100 meters. So when we use the map function, we are iterating over all the wildfires and creating one raster like this. So I will start executing this because it will take a minute or so. And the last thing to note is that I'm adding here the field argument. So this is this column that we created before with the number 1. So this means that this raster will take as the background the value 0. So this purple is the value 0, and the field that we are rasterizing will take this value. So this means that the yellow pixels will take the value of 1, which is the one that we specified before. Alright, here we go. Now we have it, and this is another list with the same length as the one that we saw before. I can try to print it in the console, but yeah, it will take a while. Maybe it wasn't a good idea. But in the meantime, I will explain you the next function. So here we have it. So we see now again that we have here a total of 1000 different elements, and each of them is one spat raster. And we can use the plot function in the wildfires raster list, and I can take a specific element. So if I take the first one, it will be the same that we saw before. So there we have this wildfire, and if I plot the second element of the list, So we have one wildfire here. And like that we have 1,300 different wildfires. So now what I will do is to reduce this list. And what this means is that we will take one list of a specific length and the final element won't be a list anymore. So we want to reduce this list by summing up all the elements. Because remember, each of the yellow pixels is 1. So it means that here we have one wildfire. But if we are putting above this or overlapping another raster and we are summing them up all the time, we will get the total number of wildfires in each of the pixels. So I will execute it. And now that we have it, we can plot it to check the final result. So there we have it. We cannot see very well this legend, but those are values from 1 to 6. So, or actually this first color is the NA value because or the 0 value, because you can see that outside of the boundaries of Ourense we are not counting the wildfires. So this purple is the value 0, and the yellowish the color, the more the wildfires we have. Another thing that might be important for creating our visualization is to convert to NA where we have values equals to 0. So I will execute this function and I will convert the final raster into a factor, so it will be a categorical raster. And if I plot it again, you will see that now we have only values for the areas where we have actually any wildfire. And the areas where we have 0 wildfires, they are NA values. Alright, so we will go to the last part of the analysis, which is calculating the burnt area. So here I'm taking the wildfires of Ourense and I'm creating the union. So if I copy this and I pipe it into the map view function, eh, okay, we don't see anything. I don't know if this is an error of positron with the map view package when we use this function. So maybe I will use just the plot function instead. Okay, so there we have it. So what we do with union is to combine all the polygons, so there are no overlapping polygons anymore. So here you remember that we had many wildfires in the image before. So that means that there we have many different polygons, but what we did it was to combine them, actually to dissolve them into one only polygon there. So now we can pipe it into the st area function, and with that we are calculating the area of all these polygons. And if I print it in the console, we have this big number in square meters. The next step is to calculate the area of Ourense. We can use the expanse function, and we are using different functions because this is an object of the SF package, and this one is from the Terra package. So if I print it in the console, we have also the area in square meters, and then I'm calculating the burnt area relative to the province of Ourense, and then I'm rounding to 2 decimals. So I will print this, and we can see that at least once 29% of the area was burned, at least once. So the final block of this tutorial is to create the map. And to create the map, we need to create two pieces. First, the main map, which is this piece of code, and finally the inset. And here I see that this function, you see that it has this underline, and this is because I forgot to load one package, and this package is the GG spatial, so I will add it here and load it again. So now I will go down, and you see that now it's not underlined anymore. So yeah, we were in this, so we have one main map, the inset map, and the combination of them. So we will start with the main map. So here I'm using the geomspat vector function to add the spat vector of the province of Ourense in this gray color. Then I'm adding the wildfires with the geomspat raster function. These two functions are from the tidyterra package. So there we have it, not a very cool map yet, but here with the scale fill manual we will change the name of the legend to number of wildfires. We will use a red palette and I will convert the NA to, or I actually will make the NA to disappear from the map. And now this looks much better. So the next step with the guides function is to customize this legend. So I'm using the position inside, so it goes inside the plot. The direction in this case now is horizontal, it's not vertical anymore. The title is in the top of the legend, is justified in the center. The label position is in the bottom of the legend. We have only one row and then the dimensions of the keys. Then I'm adding this theme void, which will take away all the background color and the axes. There we have it. And then with the theme function, I'm converting the text to white color, the plot background to black, and then I'm setting the position of the legend to be a bit upper. So it's in this position there. And finally, with annotation scale, I'm creating one scale that I'm adding down here. So it's this one right here that we added with the GG spatial package. So now I will execute this and we will create the inset map. So here I'm adding the world map that we saw before also. Then I'm adding the province of Ourense. We won't see actually very much, but we see a bit of red right there. And then I'm using the chord SF function to set the limits of the axis. So we will make zoom to Spain. So there we can see it much better. And then I'm adding the theme void and also the theme to have also the same color as before. So it will be filled black. And this color is the outline. So we don't see it very much here, but we will see it when we add it to the final map. So I'm saving this as inset_gg and then I'm using our main map and then the inset element function to add the other map. So here with the p argument we specify the element that we want to add to the other element. So we want to add this one to this other one. And here we say the dimension. So we want it the left to be 80% of the total length, to be to 100%, and then from 0, or actually from 0.8 to 1, and from 0 to 0.2. And I want it to align to the full plot. Then I'm adding some annotations with the plot annotation function, which are the title, the caption, and finally some different customization of the elements. So modifying the text to white, there's some formatting for the plot title, so it has this font family, it will be bold, the size will be a bit bigger, and so on. And here we have the final map.